right, this is the last section of chapter 1, and we are solving absolute value by cases. And I want to talk about how to break down into cases. And it's using this definition of absolute value that you take the stuff inside, and if the stuff inside is greater than 0 or equal to, you get itself. But if it's less than 0, you get the opposite. Okay, so we're going to set this up. The key is to compare our solutions with the interval they come from. And to find that interval. So here we're wondering, when is 5x plus 4 greater than or equal to 0? And if you subtract 4 and divide by 5, you get x greater than or equal to negative 4/5. So when we're greater than or equal to negative 4/5, you're solving this equation. 5x plus 4 equals 9x minus 12. When you're less than 4/5, negative 4/5, we're solving the opposite of the stuff inside, that. Okay, and so here you end up with 4x equals 16, and you get x equals 4, which is greater than or equal to negative 4/5, and so that will be a solution. Over here, we're solving this, and if you add that, you get 14x, and you add that, you get 8, and you divide both sides by 14, you get 8/14, which would reduce down to 4/7. Is that less than negative 4/5? No. So that's not going to work out. And you could actually try it out and see that it doesn't work. Okay. But it comes in really handy when you start seeing stuff like this, because here we're wondering, okay, when is x minus 6 greater than or equal to 0? Well, when x is greater than or equal to 6, we're going to use x minus 6 when that's the case. And we'll use negative x plus 6 when x is less than 6. Okay. Similarly, if we solve this, 4 minus 2x, when is it greater than or equal to 0? Well, I'll add 2x to this side. We get 2x is less than or equal to 4, and x is less than or equal to 2. That's when we'll use 4 minus 2x. But when x is greater than 2, I'll take the opposite. I'll write it as 2x minus 4. Okay? So we have different cases now. And if you set these up on a number line where you put in 2 and 6, then you can start to see, okay, when we're over here, we're less than 6. So we're going to be here. So this is case 1. We'll use this guy. And we are also less than or equal to 2 and this guy. So for this case 1, we're going to solve negative x plus 6 equals 4 minus 2x. And the answer we get, if it's less than 2, is a good answer. Okay. In this middle section, we're greater than 2, so we got to say 2x minus 4 right here. And we're still less than 6 equals negative x plus 6. Okay? And if that answer is between 2 and 6, it's a good answer. And then third case is over here, where we are now greater than 6. So we're using this guy, x minus 6 equals, we are greater than or equal to 2. So we're stuck using this guy again, 2x minus 4. Okay? And now we solve all three. We add 2x and we get x. We subtract 6 and we get negative 2. Is that in this range? Yes, it will work. We can add x and we get 3x. We can add 4, we get 10. And we divide both sides by 3, we get x equals 10/3. Is that in between 2 and 6? Yeah, it's about 3 1/3. Okay? So that's going to work. Here, we add 6 and subtract x, or actually I'll subtract x and add 4. So here we get x equals negative 2. Is that in that range? No, but we've actually already eliminated it, so I'm not too worried about it. So we have two solutions. The set of negative 2 and 10/3. Okay? How about what happens when we're dealing with stuff like this? Okay? If there's a single absolute value, we got 2 cases. When there were 2 absolute values, we got 3 cases. And when there's 3 absolute values, you get 4 cases. So I started this out for us. Okay? This one, the turning point is at 0. Okay? I just basically pick out when does this equal 0, when does this equal 0, and I figure out when it's positive or negative. Okay? So here's 0, or nope, I want to put negative 5 on there. Here's negative 5 on this side, and here's 0. So case 1 is when we're below negative 5. So case 1 will use this, and below 0. Okay? So we would say negative x equals negative x minus 5 and solve that. Case 2. is when we are above -5 and below 0. So we're going to say negative x equals x plus 5. And then finally, case 3 is up here where we are above -5 and above 0. And we'd say x equals x plus 5. Hopefully you realize that these x's cancel and we get 0 equals -5, which is no solution. Here we get -2x equals 5, and we divide by -2, and we get x equals -5/2, which is in the interval, so that works. And here the x's cancel, we get 0 equals 5, so there's no solution. So that's my only answer, okay? But it narrows it down to the number of cases we need to try, and it's very easy to check and see if it would actually work, okay? And then lastly, if we do this, notice this, we're dealing with 0, -1, and -3 are the numbers. So I'm going to put those on my number line, -3, 0, 1. Case 1, if we're below -3, we're on the negative side of this, the negative side of this, the negative side of this. So I would say for case 1, I'll put case 1 up here, -x minus x minus 1. I'm going to make this the opposite, which is going to cancel with this. We're going to get plus x plus 3 equals 12. Okay, so it's just a matter of making this thing negative, and this thing negative, which cancels with that negative. Okay, case 2, we're on the other side of this one. So this one's going to stay positive now. We're on the positive side of -3, but these both need to become negative. So case 2 is going to say -x minus 1, and then this is staying positive, so it's going to distribute that negative. -x minus 3 equals 12. Case 3, I know it's starting to get messy. So case 3, we're right here, and now we're on the other side of 0. So this guy's going to stay positive, and we're going to get x minus 1. This guy stays positive. We're still to the left of that -1, so we're still going to be getting negatives here. That's why I switched that sign, or distributed a negative through there. Here, we're going to be positive, but we have to distribute that negative through, equals 12. And then case 4 is where we are way over here. What color? Let's go here. Okay, case 4, we're way over here. And so we're taking the positive of that, the positive of that, the positive of that, and we just get x plus 1 minus x minus 3 equals 12. And these are the 4 cases, okay? And we want to check on our number line to make sure everything works. So the -2x's and this x, we end up with -x plus 2 equals 12. And so if I move the x, we get -10. And that checks out. That's in the right vicinity. This black one was next, case 2. So we get -3x minus 4 equals 12. We add 4 and we get 16. -3x equals 16. And x equals -16 thirds, which is about -5, not in the interval. Toss it in the trash. Right here, we get negatives, battle with that. We get -x minus 4 equals 12. And we add that. We end up with x equals -16, not in that interval. Throw it in the trash. And then here, we end up with 2 minus 1. We just get an x minus 2 equals 12. X equals 14. That is greater than 1. So that one checks out. And so we get these 2 solutions, -10 and 14. So number line to set up your cases, and then you get to determine, do I keep the positive of that absolute value because we're on the good side where I would get a positive number anyways, or do I take the opposite of that absolute value? And fill in the blanks, set them up, solve them, and you reduce the number of cases that you got to worry about. All right, so good luck and farewell.